Hi, I'm Cara de la Marck. I'm a Senior Ecosystem Advocate at the Continuous Delivery Foundation. Continuous delivery is a software development practice that enables developers to release small but frequent software updates reliably and safely. Closely linked to the broader DevOps movement, continuous delivery consists of a set of practices that aim to automate and streamline the software delivery process. These practices in turn allow developer teams to innovate faster by collecting regular user feedback and prioritizing the product features and fixes that matter. The Continuous Delivery Foundation is pleased to share vendor-neutral data on key DevOps and development metrics showing where continuous delivery stands in 2020. The Continuous Delivery Report series started last year. This is the third report in that series. This latest report has just been made available this week, and you can view the report on the link on the slide for free. The findings in this report are based on data from /Data's past 4 Developer Nation surveys, which reached more than 70,000 respondents worldwide over 18 months, from Q3 2020 to Q1 2022. The report examines to what extent developers have embraced continuous delivery practices to increase the effectiveness of their software development and release process. In this report, commissioned by the Continuous Delivery Foundation and authored by /Data, we explore the current state of the continuous delivery developer ecosystem and how this has evolved over the past year and a half. In the report, we will see how developers' software delivery performance has changed over time. Today, we'll go over some of the results of the latest State of Continuous Delivery report, going from high-level takeaways to diving deeper to the current state of continuous delivery practices by examining DORA metrics, and then exploring technologies, including microservices and cloud technologies, that this report shows help teams improve their continuous delivery capabilities. So let's look at some key takeaways. As of Q1 2022, less than a quarter, that is 23%, of developers are not involved in any DevOps-related activity. This indicates continued growth in the adoption of practices that increase an organization's ability to deliver software at high velocity. We've seen an increase in DevOps adoption in nearly every department sector, including mobile app development and desktop development. However, only 1 in 5, 20%, up from 18% in 2021, use both continuous integration and deployment approaches to automate all the building, testing, and deployment of code to production. Around 1/3 of developers manually approve code deployments to production. This demonstrates that fully automated software delivery pipelines are still not pervasive. Interestingly, this report shows that medium-sized and especially large enterprises are experiencing the most significant growth in DevOps adoption and the benefits thereof. Large enterprises are becoming the most significant beneficiaries of DevOps practices. For example, in large enterprises, the proportion of low performers for lead time for code changes has dropped significantly, from 34% to 24% in the last 6 months alone, while the proportion of top performers has also increased from 13 to 21%. We'll go over what those metrics mean in a minute. In addition, though, large enterprise developers also see a significant improvement in the proportion taking less than 1 hour to restore service, now at 22%. And in the proportion taking more than 1 week, falling from 23 to 18%. What does this mean? And how is all this being measured? DORA metrics help us to measure software delivery performance and are also predictive for organizational performance. DORA, the acronym, stands for the DevOps Research and Assessment Team, and they are the team that developed these metrics. You can learn more about DORA metrics in the phenomenal book, Accelerate, the Science of Lean Software and DevOps, Building and Scaling High-Performance Technology Organizations, co-authored by Nicole Forsgren, Jez Humble, and Jean Kim. These metrics are often used to give a large overview of CI/CD and DevOps practices generally, as they are within the state of CD report itself. However, from the point of view of teams, often an even more useful way to use them is as a benchmark for your team, and then try different iterations of improvements in your DevOps practices, depending on what your team deems most vital and immediate and important to improve or fix. And then use DOOR metrics again to see what effect those efforts had and to measure that effect. DOOR metrics have revolutionized the way DevOps teams operate, as these metrics create data that can be used as a base for improvements and evaluating those improvements. A different way to make use of DOOR metrics, and this is how they are used within the industry studies, as with this report. The DOOR metrics are used to group low performers or elite performers across various metrics and to say what that means exactly. The 4 metrics which make up DOOR metrics are deployment frequency, lead time for changes, mean time to recovery, and change failure rate. Deployment frequency refers to the frequency of successful software releases to production. So it measures how often code is deployed. Lead time for changes captures the time between a code commit and the time it takes for that code to reach production. In order to measure lead time for changes, 2 pieces of data or timestamps are required: the exact time of the commit and the exact time of the deployment. Lead time for changes measures the velocity of software delivery. The lower the lead time for changes, the more efficient in deploying code. If a high lead time for changes is detected, DevOps teams can install more automated deployment and review processes and divide products and features into much more compact and manageable units. Change failure rate indicates how often a team's changes lead to failures after the code has been deployed. This metric captures the percentage of changes that were made to a code that then resulted in incidents, rollbacks, or any type of production failure. Mean time to recovery measures the time between an interruption due to deployment or system failure and full recovery. It measures the time it takes for a service to bounce back from a failure. It doesn't matter how high performing a DevOps team is, unplanned outages or incidents happen. And since failures can't be avoided, it is really the time it takes to restore or recover a system or application that makes a difference. In order to improve in regards to mean time to recovery, DevOps teams have to practice continuous monitoring and prioritize recovery when a failure happens. It is also helpful to establish a go-to action plan for an immediate response to a failure. So why should every DevOps team use DOOR metrics? The answer is pretty simple. If there is no data that measures performance, it is difficult or nearly impossible to make any improvements. In the State of Continuous Delivery survey, /data analyzes 3 of these, namely lead time for changes, deployment frequency, and time to restore service. So what do we see from analyzing the data? First, for lead time for changes. Despite a small increase in the percentage of top performers, those with a lead time of less than 1 day, from 14% to 16%, and a decrease in low performers, lead times of more than 1 month, compared to 6 months ago. Q1 2022 performance metrics closely resemble those of 2020. However, when we focus specifically on large enterprises, we find that the percentage of low performers for lead time for code changes has dropped significantly, from 34% to 24% in the last 6 months, while the proportion of top performers has also increased from 12% to 21%. There is no such sizable shifts among developers in small and medium-sized businesses, indicating that large enterprises are becoming the most significant beneficiaries of DevOps practices. Number 2, deployment frequency. So for deployment frequencies, Q1 2022 sees the smallest proportion of low performers, those deploying code less frequently than once per month, at 33%. However, the proportion of top performers with multiple deploys per day remains stable at 11%. Hence, it appears that growing engagement in DevOps may be helping to raise the minimum standard, but is less effective at enabling even more to achieve excellence. Number 3, time it takes to restore service. There was a steady deceleration in the time it takes to restore service across the 3 surveys from Q3 2020 to Q3 2021. However, in Q1 2022, this deceleration appears to have abated. There is no change in the proportion of top performers and only a 2 percentage point decrease in the share of low performers. 30% of all DevOps practitioners take more than 1 week to restore service. As with lead time for code changes, it is large enterprises who appear to be bucking the trend, with a significant improvement in the proportion taking less than 1 hour to restore service, rising from 17% to 22%, and in the proportion taking more than a week, falling from 23% to 18%. There remains a strong correlation between speed and stability metrics, rather than one compromising the other. Over half of developers for whom it takes more than 1 month to commit code changes also perform poorly in restoring service, taking more than 1 week. By contrast, less than 10% of high performers in software delivery speed are low performers in stability. Similarly, nearly a third of top performers in lead time for code changes excel in time to restore service. In comparison, only 5% of low performers in software delivery throughput are high performers in stability. This year, for the first time, we asked Slash Data to explore the relationship between software delivery performance and evolution in approaches to building software. For example, moving from monoliths to microservices and scaling applications with container-based infrastructure and orchestration tools. Slash Data found the adoption of backend technologies such as microservices, containers, and Kubernetes generally correlates with improved performance for lead time for code changes and time to restore service, but fails to significantly improve deployment frequency. Modern backend technologies and architectures, such as microservices, enable software systems to be structured in a way that is intended to enable rapid, frequent, and reliable delivery via loosely coupled, highly maintainable, and independently deployable applications. Indeed, our data reveal that developers who use microservices are 2/3 less likely to be low performers in lead time for code changes than those who do not use microservices. The difference is 22% versus 33% respectively. They are also 60% more likely to be in the top performing group with a lead time of less than 1 day than those who do not use microservices at all, 24% versus 15% respectively. Those using containers are twice as likely to have lead times of less than 1 day compared to those not working with container technologies. Likewise, Kubernetes users are 1/3 more likely to be top performers than those who do not use the technology. There is a strong correlation between the breadth of individual developers' involvement with DevOps technologies and their likelihood of being among the top performers in terms of lead time for code changes, deployment frequency, and time to restore service. The more DevOps technologies a developer uses, the more likely they are to report delivery performance improvements. Additionally, Slash Data found that there's a strong correlation between the breadth of individual developers' involvement with DevOps technologies and their likelihood of being among the top performers in terms of lead time for code changes, deployment frequency, and time to restore service. The more DevOps technologies a developer uses, the more likely they are to report improved delivery performance. This points to the importance of interoperability amongst CI/CD tools. In her PhD and postdoc, Nicole Forsgren found that how well a tool is integrated into the rest of a developer's tools is super predictive of how for performance for technology professionals. One of our goals of the Continuous Delivery Foundation is to promote greater interoperability between CI/CD tools. We recently launched the CD Events project, which is being developed within and by the CDF Event SIG. CD events are a standardized event format for the continuous delivery ecosystem. We define an event following Cloud Events definition as a data record expressing an occurrence and its context. So the focus of CD events is on data and exchanging that data across various tools and systems employed by an organization through their CI/CD system. So why are we developing CD events? Well, today's CI/CD systems do not talk to each other in a standardized way. This inhibits interoperability and reduces automation while necessitating the creation of glue code, which is incredibly expensive and time-consuming for developer teams to maintain. CD events enables developers to have a common way to describe events in CI/CD systems instead of writing event handling logic for each event source. CD events are an enabler for interoperability between different CI/CD tools as they provide a tool-agnostic communication protocol between event sources. Using events also increases automation while connecting workflows from different systems to each other, and as a result empowers tracing, visualization, and auditing of the connected workflows, as well as increased productivity and developer performance as per Nicole Forsgren's research. We hope you find the State of CD report as enjoyable and informative as we do. Thank you.